Yes, sir.
Anyone?
Yes, sir.
Okay, right, fine. So we can start, right? So, good morning, students. Right. So last class we discussed. Just a second. Right. So is my screen is visible to full screen mode?
Yes, sir.
Yes, sir.
Okay, fine. Okay, right. So last class we discussed about what is as standard cycles, right? What is as standard cycles and what are the assumptions we have to consider for an as standard cycles, right? So for the same, today we are going to discuss about the fuel air cycles. Fuel air cycles. So in this fuel air cycle, difference between air standard cycle and fuel air cycle.
Sir, my voice
Your
break
mic.
by break again,
Okay,
sir.
right, fine. Sorry. Voice is breakable. Just wait. Now it's clear. இப்ப
Yes,
கேக்குதாப்பா?
sir.
Okay, right, fine. So first we is fuel air cycle and what is the difference between the fuel cycle and air standard cycles, right? So let's see the assumptions twice, right? So for the air standard cycles, what is the working fluid? Anyone? For the air standard cycles, what is the working fluid? Am I audible?
Yes, sir. Audible.
Right. Then tell me what assumption we have made in order sir, air standard cycles. What are the assumptions? Do you remember for the air standard cycles?
Ideal gas.
Anyone?
Ideal gas.
Ideal gas, right? So the working fluid will be the ideal gas in air standard cycle, right? But in fuel air cycle, we are using the fuel as well as the mixture of fuel and air is used as a working fluid in fuel air cycle, right? So that's the first major difference between the air standard cycle and the fuel air cycle. So we can define the fuel air cycle in easy manner. The theoretical cycle based on actual properties. The theoretical cycle based on the actual properties of the fluid which will contain in the cylinder is called fuel air cycle, right? So for the air standard cycles, fluid is a only air with constant specific heat. But in fuel air cycles, we are considering the mixture of fuel and air as a working fluid. So we can obtain a different properties, right? So that property is called as the actual properties, right? So depending upon the properties, the fuel air cycle efficiencies may vary, right? The fuel air cycle depends on the actual properties of the working fluid and the amount of fluid, the amount of fuel contains in the mixture, right? So depending upon these two, the air cycle and the fuel air cycle efficiency may vary, right? So the first term we can define, how we can define the fuel air cycle. It is a theoretical cycle, right? It is a theoretical cycle based on the cylinder. The cylinder contains the actual properties of the working fluid. The working fluid will be the mixture of fuel and air. Fuel and air mixture will be used. So depending upon the amount of fuel will be used, right? So the amount of fuel we can classify what is lean mixture and what is the rich mixture, right? So what is lean mixture and what is the rich mixture? Means the fuel, that the amount of fuel will be comparatively low. The amount of fuel will be comparatively low in the mixture, means it is called as lean mixture. That is called as lean mixture. The fluid is high, so it is called as rich mixture, right? So depending upon these two, right? So the amount of fuel and the actual properties of fuel, these, right, these two impact a major effect on the efficiency of the air fuel cycle, right? So here also we have some assumptions, right? Here also we have some assumptions for the air fuel cycles, right? So what are the assumptions, right? Then the factors, right? So first four, see, these four will be the factors. These four will be the factors for the air fuel cycle, and some assumptions also there. So first we can see the assumptions, after that we can see the factors, right? So what are the assumptions, right? So here we have plenty of assumptions, right? So the first assumption, the compression and the expansion process are frictionless. The compression and expansion process are frictionless. Why? Because there is no heat exchange between the gases and the cylinder wall in any process, right? So note that there is no heat exchange between the gases and the cylinder wall in any process, right? So that processes are called as the adiabatic, right? In addition, expansion and the compression process are the frictionless, right? So that is the first assumption, right? So it is the first assumption. Then the second one, and there is no chemical change either in the, so before the combustion, in period to the combustion, before the combustion, the chemical changes either in the fuel or air, either in the fuel or air. That is the second assumption, right? Then the combustion takes place, that is the burning, right? The burning takes place instantaneously at the TDC. Instantaneously at the TDC, the combustion takes place instantaneously at the TDC, right? So in the air standard cycles, what we assumed, the combustion will be takes place slightly, the piston moves to the TDC, right? So before reaching the TDC region, the combustion will be starts. But here the combustion will takes place instantaneously at the top dead center, right? So we already told in this assumption, right? So there is no heat exchange between the gases and the cylinder walls. So the process is called as the adiabatic. So all the process are called as the reversible adiabatic process. Then the fuel is completely vaporized and perfectly air, right? The fuel is completely vaporized and perfectly mixed with air, right? So this is a main advantage. That's called the air fuel mixture. That is called the air fuel mixture. Then the subsequent combustion, the changes the chemically equilibrium, right? The changes is always in chemical equilibrium. So these are the assumptions, right? These are the assumptions, right? So one is the process, the compression as well as the expansion process, or the frictionless process. That is a work in and work out. That is the work in and work out, or the frictionless process. And there is no chemical change. There is no chemical change to the period of the combustion. Before the combustion, there is no chemical change in the air fuel mixture. That is fuel and air, and the combustion will take place instantaneously at the top dead center, and there is no heat exchange between the gases and the cylinder walls. So that process called as the adiabatic. So the entire cycle will be considered as a adiabatic cycle, and the fuel is completely mixed with air. The fuel is completely mixed with the air, right? That is called the fuel air ratio, mixture of fuel air, right? Then the subsequent combustion, the changes in the change is always in chemical equilibrium. Chemical equilibrium, right? Is it clear? So these are the assumptions are made while considering a fuel air cycle, right? Is it clear?
Yes,
Anyone?
sir.
Okay, right, fine.
Yes, sir.
So now we can see what is fuel air cycle, right? The theoretical cycle based on the actual properties of the cylinder is called the fuel air cycle, right? It provides the rough idea. It provides the rough idea for the comparison with actual performance, right? So the as standard cycle, in the as standard cycle, it gives an estimate for engine performance is much higher, right? It's much greater than the actual performance, right? So for the example, uh, the the thermal efficiency of the petrol engine, for the compression ratio of 7:1, for the compression ratio of 7:1, in order to get 15%, in actual engines, in the actual engines, the thermal efficiency for the compression ratio of 7:1 is 15%. But in as standard cycle, the efficiency will be 54%. The as standard cycle, the efficiency will be 54%, right? So why this much of deviations? Why this much of deviation means the values of the working fluid for the cycle analysis, right?
Sir,
So
voice
for the
break.
values of the property, எப்ப எல்லாருக்கும் பிரேக் ஆகுதாப்பா?
Yes, sir. Break out.
எல்லாருக்கும் பிரேக் ஆகுதா? ஓகே ரைட். ஸோ நான் கொஞ்சம் ஸ்லோவா பேசுறேன், ஓகேவா? கொஞ்சம் ஸ்லோவா பேசுறேன், ஸோ we can reach that one. In actual cycle, the thermal efficiency of petrol engine for the compression ratio of 7:1, in order to get 15% of efficiency, but in as standard cycle, we can get 54% of efficiency for the same compression ratio of 7:1, right? So why the reason for this divergence, right, is the values of the properties of the working fluid, for the cycle analysis, and the non-instantaneous burning and the valve operations and the incomplete combustion, right? So these are the reasons the efficiency may get affected, right? So one is the value of the properties of the working fluid and the non-instantaneous burning and the valve operations. So these are the reasons, right? These are the reasons or the factors. This causes the efficiency effectiveness, right? So the factors, right? So what are the factors which may considered in a fuel air cycle? So the first one is the actual composition of the cylinder contents, right? So the first one is the actual composition of the cylinder contains, right? So the cylinder gases contain fuel, air, water vapor, and some residual gases, right? So this is the actual composition inside the cylinder in fuel air cycle, right? So what are the terms are there? So fuel, air, water vapor, and some residual gases, right? So during the operation of the engine or system, the fuel air ratio changes, which changes the relative amount of the carbon dioxide, water vapor, and etc., right? So the outputs, right? So what are the exhaust terms, right? What are the exhaust combustion terms, right? Then the second one, in air standard cycles, we are considering the specific heat is constant, right? In air standard cycles, we are considered the specific heat is constant, but in fuel air cycle, there is a variation in the specific heat. There is a variation in the specific heat. So due to the specific heat, the performance may, the efficiency may varies, right? So the cycle diagram also the varies there. So the specific heat increases the temperature. The specific heat increases with the temperature, right? So inside the cylinder, the temperature will be above 1500 Kelvin, 1500 Kelvin. So automatically the variation in specific heat occurs, right? So the specific heat will be varies with rising in the temperature, but it is except for monoatomic gases. But it is except for monoatomic gases. Monoatomic gases, there is no variation in the specific heat. But in our case, we are using the actual composition, that is the fuel, air, water vapor, and some residual gases are there in the engine cylinder. So surely the variation in the specific heat will be there, right? Then the third one is the dissociation effect, that is the disintegration, right? Disintegration of the molecules, disintegration of the terms. The fuel air mixture does not completely combine chemically at high temperatures, right? So the fuel and air mixture does not completely combine chemically at high temperatures. So therefore, at the equilibrium conditions, the gases like carbon dioxide, hydrogen, oxygen may be present in the cylinder, right? So due to that, what are the effects are there, right? That we have to study, right? That is called dissociation effect, right? So the disintegration of the components, right? How it can be affect the engine while in the operating condition, right? Then the fourth one, that is the fourth factor, is the number of molecules present in the cylinder, that is the number of moles, right? Number of moles present in the cylinder as the pressure and the temperature changes, right? So these four factors are important in fuel air cycle, right? So in this class we can see the one by one factors, right? So the first factor is the actual composition of the cylinder contains. So in the actual composition of the cylinder contains, I already told that. So what are the terms? What are the terms inside the cylinder? Means the fuel, air, water vapor, and some residual gases, right? So these are contained in a fuel air cycle, right? So the change, right? The air fuel ratio changes during the engine operation. This change in air fuel ratio affects the composition of the gases, the before the combustion as well as the after the combustion, right? So the changes in air fuel ratio affects the composition, right? See, the change in air fuel ratio affects the composition of the gases before and after the combustion. So after the combustion means particularly the percentage of these contents, particularly the percentage of carbon dioxide, carbon monoxide, and the water vapors in the exhaust gas, right? In the four-stroke engine, the fresh charges, right? In the four-stroke engine, the fresh charges as enters in the cylinder comes in contact with some burned gases left in the clearance space, right? See the fresh charges, right, in four-stroke cylinders, right? The fresh charges of the gas comes into the contact with the burned gases. So sorry comes right. The amount of exhaust gases varies with its load and the speed. The amount of exhaust gases in the clearance volume varies with load and the speed of the engine, right? So intake condition, so the air fuel mixture is there, right? Air fuel mixture is the major component, and we have, see, the air fuel mixture, right here, the air fuel mixture and some water vapor and some residual gases, right? In the intake condition, we have air, fuel, and the residual gases and some water vapor right? It is in the intake condition. And the compression, at the compression stage also we have the same, right? Why? Because we have some assumption. What is that assumption? Before the compression, in period of the combustion, there is no chemical changes occurs, right? So these are the main assumptions. See, in period of the combustion, there is no chemical change. In fuel and the air. So the intake and the compression, these are the same, right? While it is in burning, right, after the burning, the composition, it may have some chemical changes, right? So we can get the combustion products of the carbon dioxide, carbon monoxide, water vapors, hydrogen, nitrogen, right? So these are the emission conditions, right? These are the products we can get at the combustion process, right? And the same will be gets out to the exhaust condition, right? So then the same will be gets out to the system in the exhaust condition, right? So these are the terms will be there in the actual composition of the cylinder, right? So is it clear? The first factor, இது புரிஞ்சா first factor? anyone?
Yes, sir.
Okay, right.
Yes, sir.
Right. So the first one is the actual composition of the cylinder. So first factor, புரிஞ்சிலையா first factor? What is the first factor? The actual composition of the cylinder contains, right? So என்னென்னலாம் இருக்கும்? In the cylinder we have a fuel, air, water vapor and residual gases in the intake, and the compression same இதே தான் இருக்கும், but there is no chemical change. ஏன்னா நம்மளுடைய அசம்ஷனே அதுதான், ரைட்டா? So before the combustion there is no chemical change. So the suction stroke and the compression stroke, அதுல நமக்கு வந்து combustions கிடையாது. So there is no chemically change, ரைட்டா? So எந்த ஒரு chemical changesம் அங்க இருக்காது, ரைட்டா? So after getting the combustion, so burning of these items, we can get some molecules. அந்த molecules என்னென்ன இருக்கு? So carbon dioxide, carbon monoxide, hydrogen, oxygen, ரைட்டா? So அதே மாதிரி NOx conditions, ரைட்டா? So nitrous oxide, இந்த மாதிரியான emission conditions எல்லாமே இருக்கும் at the burning condition, ரைட்டா? burn ஆனோடனே நமக்கு என்ன ஆகும்? The chemical எல்லாமே என்ன இருக்கும்? chemical equilibrium, but it may have some chemical changes, right? So that is called as the combustion product. Or this combustion product will be going out to the exhaust system. Okay, is it clear இல்லையா? So இது என்னது? actual composition of the cylinder contains. contains, right? So the second one பார்க்கறது முன்னாடி நமக்கு இது ஒரு கொஞ்சம் இம்பார்ட்டன்டான டேர்ம் இருக்கு, ரைட்டா? The fuel cycle analysis takes into the account, in fact, the results are computed using the combustion charts, right? So the numerical values, right? So the effects of the cylinder composition and the performance will be computed, of the numerical technique. The numerical technique means the combustion chart, right? So earlier days we are using the combustion chart, but in nowadays we have plenty of facilities, right? By using the computers we can done all these results, right? So by using the computers we can get all the results in fast and accurate manner, right? So the effect of the composition inside the cylinder, and the performance will be calculated or computed by means of the combustion charts in earlier days. அது பேர் என்னது? The numerical techniques னு சொல்லிருக்கோம் இல்லையா? The numerical techniques is a combustion chart, right? So அந்த combustion chart ன்றது உங்களுக்கு எப்படி இருக்கும் நான் ஒரு லாஸ்ட் கிளாஸ் காட்டுறது, right? So in earlier days we are using the combustion chart, but nowadays we have plenty of advantages, advancements, right? So we are using the computers in all the domains, right? All the domains we can use the computers. So by using the computers we can get the results in faster manner as well as the accurate manner, right? So fastaவும் accurateவும் நம்மளால வந்து நிறைய ரிசல்ட்ஸை எடுத்துக்க முடியும், ரைட்டா? ரைட். Then the second factor is a variable specific heats, right? In air standard cycle we are assuming that constant specific heat, right? We are assuming constant specific heat, but in fuel air cycle there is a variation in specific heats depending upon the temperature, right? Depending upon the temperature rise, right? So when we can get the variation of specific heat means with the rise of the temperature. Surely the specific heat may vary, may get some variations, right? So except for monoatomic gases, but in air fuel cycle we are using the polyatomic gases, right? We are not using the monoatomic gases, right? So for the air standard cycle we are using the only the air or perfect ideal gases, right? So that is called as the monoatomic gases. But in fuel air cycle we are using the blend air fuel mixture, so it is not a monoatomic gases. So surely the specific heat variation will be there, right? So inside the cylinder we can get the temperature above 1600 Kelvin, but the specific heat variation is linear between these temperature range, right? Between 300 Kelvin to 1500 Kelvin the specific heat curve will be a straight line, right? So the specific heat will be in straight line. It may be expressed this equation, and we already, so gas constant is a in Cp minus Cv, right? We already know this term. In thermodynamics itself we can study these terms, right? So the specific heat in any substance is the ratio of the heat required to rise the temperature of the unit mass of the substance through 1 degree, right? Through 1 degree Celsius temperature, right? In gases the temperature can be raised in two ways, either in constant pressure and the constant volume, right? Accordingly we have two specific heats, that is Cp and Cv, right? The specific heat varies largely with the temperature but not so significantly with the pressure except at high pressures, right? So why these pressure variations, why these specific heat variations are there, the reasons, right? the internal energy of the gases largely due to the translational, rotational, and vibrational energy of the molecules, right? The internal energy, right? So we already know the first law of thermodynamics, that is Q, which is equal to work done, and we have some internal energy. இந்த ஃபார்முலா எல்லாருக்கும் ஞாபகம் இருக்காப்பா? Q is equal to W plus or minus del E. ஞாபகம் இருக்கீங்களா இந்த ஃபார்முலா எல்லாருக்கும்? Anyone?
Yes, sir.
Okay, right, fine.
Yes, sir.
So the del E is the internal energy. The internal energy of the gases largely changes due to the translational, rotational, and the vibrational energy of the molecules. Correct? Right. The energy of the vibration increases rapidly with the temperature. Right? So நம்மளுக்கு வந்து ஒரு object type questions இருக்கு, gate question, right? So the internal energy depends on, அப்படி போட்டு நிறைய ஆப்ஷன்ஸ் கொடுப்பாங்க, pressure, volume, temperature, and so on, so right? So the internal energy is mainly depends on the temperature, right? The internal energy mainly depends on the temperature. If the temperature increases, automatically the internal energy increases. எப்படி சொல்றோம் அப்படின்னா, the energy of vibration increases. The energy of vibration rapidly with the temperature, right? Right. The specific heat must increase to account for absorption of the energy, which increases the vibration. Will undergo considerably also the specific heat. So the change. Correct, fine. Am I audible?
Yes, sir. Audible.
Okay, right. So இப்போ டைம்
Yes, sir.
டைம் இருக்கா இல்ல இன்னும் கொஞ்சம் எடுத்துட்டு போலாமா, இல்ல மத்த நெக்ஸ்ட் கிளாஸ் பாப்போமா?
Next up,
So we can next class பாப்போமா? Okay, right. So we can stop here and we can see the remaining terms in next class. Now we have some discussion. Right now we have some discussion about this class. Okay, va? Okay, right, fine. So what are the terms we discussed in this class? So what are the terms? Jyoti Shankar. Jyoti Shankar. Right. So what are the terms we discussed in this class? What are the terms we seen in this class?
R standard.
இந்த கிளாஸ்
cycle, sir.
ஆர் ஸ்டாண்டர்ட் சைக்கிள்ஸோட அசம்ப்ஷன்ஸ் என்னன்னு பார்த்தோம். ரைட்டா? ஏதாச்சும் ரெண்டு அசம்ப்ஷன் சொல்லுங்க. ஏதாச்சும் ஒரு ரெண்டு அசம்ப்ஷன் ஆர் ஸ்டாண்டர்ட் சைக்கிள்ஸ். சேம் ஜோதி சங்கர். நிரசன்யம். நிரேசன்யம்.
Yes, sir. Yes, sir.
நிரேசன், ஃபியூல் ஏர் சைக்கிள் அப்படின்னா என்ன? வாட் இஸ் ஃபியூல் ஏர் சைக்கிள்? Unmute your mic and answer. டேய், இப்ப நீ சொல்றது தப்பா ரைட் எல்லாம் கிடையாது. ரைட்டா? we can discuss. அவ்வளவுதான். So once again we recap what we discussed in this class, right? So what is fuel air cycle? Right? A fuel air cycle, the difference between air standard cycle and the fuel air cycle is the composition inside the cylinder, right? So for the air standard cycle we are using only the air, that is ideal gas will be used in the entire cycle. But in air fuel ratio, in air fuel cycle we have a mixture of air, fuel, water vapor and some residual gases, right? So these composition will be inside in the cylinder. So automatically what will happen? It may affect some performance. It may affect some performance, right? That is the first factor, right? That is the first factor. Then the second factor is the variation in the specific heats, right? But the assumption of the air standard cycle, the constant specific heat will be used in entire cycle, but in fuel air cycle the variation will be there, right? So the variation of the specific heat will be there with rise of the temperature. This is the second factor. And the third factor, the dissociation, that is the dissociation effect, that is the disintegration of the components, disintegration of the chemical changes, after the combustion. What will happen? The mixture of air fuel ratio will be burned, right? So it may produce some gases, the chemical changes will be occurs, right? So due to the chemical changes we can get the carbon dioxide, carbon monoxide, hydrogen, oxygen. These are the contents are there. So the disintegration, right? So disintegration of these components, right? Due to this disintegration, how the engine will affect, how the performance will be affect, right? That is the third factor. And the fourth factor is the number of moles present in the cylinder as at the temperature and the pressure